Hey everybody, and welcome back. So on today's video, we're going to talk about dev containers. We're really going to start kind of setting this up as the foundational stepping stone. I'm going to start a video series that goes through kind of the different archetypes of data lake houses and how different companies are implementing those. And so if you're interested in following along, or if you have a need for a kind of a fresh environment, I figured I would start kind of at the beginning. There was a time where I was managing a lot of dependencies on my machine. So I'll give you an example. If you go through C Sharp and your legacy code is in .NET Framework and you're running in .NET Core and you're running those side by side on the same machine, there's a little bit of trickery that goes on, right? There's a little bit of dependency issues. Sometimes your Visual Studio will pick up one version and everything will have red squiggles under it, and then sometimes it'll pick up the other. And there was kind of an architecture fight there that I didn't really want to fight. One of my big things personally is developer experience, and so having a clean, reproducible environment is really helpful, right? You can even think about Node. There's plenty of times where I pulled down a code and installed it and find out that it was Node from 5 years ago, and my Node was the latest LTS version. So there was a lot of issues with that, and you have to, use NVM and get the right version together. So this kind of takes away some of that pain, right? It takes away with it works on my machine. It takes away with having to remember if you're in Python to do a virtual environment. I still use virtual environments in here out of habit, but what it does and what the dev container does nicely is it's clean, isolated, reproducible environment. Think about breaking your machine, right? How many of you have ever blue screened of death? How many of you have ever installed dependencies that clash and do the things? Forget to do a Python virtual environment, and now you have 50,000 packages on your machine, and it's such a struggle. What a dev container does is it gives you a quick, reproducible, clean environment every time. So I can drop my dev container JSON file, and I'll show you how this kind of works, into a new project, spin it up, and basically I'm working inside of Docker with a connection to it from my Visual Studio Code. So I get all the isolation of Docker. I get all of the throw it away of Docker. I get all of the build it once, run it anywhere of Docker. But now is my development environment. Now I'm working in there. So if I break it, rebuild it. If I install something I shouldn't, I rebuild the container. As long as my volumes are mapped, I can do nice cleanup. Every time I go to a new project, I know that I can configure that dev container for that new project exactly the way I want to. And then once I have my dev container, it's a matter of spinning it up locally. And then I have a junior who's working on the project. I don't want him to have to recreate a brand new environment. I have a new senior that just came in, right? You spend 2, 3 days just setting your tools up, finding out, okay, what version of this are we using? Okay, what other tools are we using? Okay, what are we using for this? And creating that local environment. Instead, you just have a repo of dev containers that you just pass around, and now you just have a clean, not only a clean environment to start from, but a clean machine. I'm not installing Java on my MacBook Pro. I'm not installing, Postgres on my MacBook Pro. I'm doing it all in a dev container, all isolated, right? There's a lot of people I work with. I had a really good friend that I work with that did things in virtual machines exact same way. And this is the same concept, just a lot lighter and a lot quicker, right? He would use virtual machines to keep his actual computer clean. Well, this is kind of that same concept, right? Keeping your machine clean and putting everything in your dev container. So, what exactly is a dev container? It's a full development container, full development environment inside of a Docker container. And that's where you're working, right? You're isolated inside of there. Now, there's a couple good things, right? Visual Studio Code connects directly to it. I can also put this on my Docker network. So if I'm running Postgres and I'm running MinIO and I'm running Nessie and I'm running all these other tools, sometimes you're going to have a lot of different ways to connect to them. Well, now I can use the container name because I'm on a Docker network and I can connect directly to them without having to play network roulette, right? I could just jump on that same network. We're all isolated. I can talk directly and everything's great. So the other part of it that I really like is reproducibility. Besides the isolation, besides all the things, I like to be able to create a container beforehand, and I'm going to show you what I've done here. And I have a public container. You could pull it down and play with it. I'll kind of show you the where it lives. But I create these, I take some time and put the things in I need, and then I publish it, and I just pull it down whenever I need it. And so no more messing up my computer. If I want someone else to use it, I just let them pull it down. They have the same environment I do. They can test it the same way. They can see what I can see. And it's becoming the professional standard and for modern data teams, right? Just because environment management and fighting the architecture and fighting your infrastructure and fighting all those things shouldn't be a thing we fight, right? Infrastructure should just work so we could develop things and data engineer things and do all the things that we do without having to worry about, am I on the right network with the right port and the right thing? Is my version matching the right thing? I played around with Spark heavily the last few weeks, and you want to talk about version dependencies with Spark and Hadoop and file systems and trying to connect to MinIO and just the AWS side of it, like all these packages and connectors have different versions for different versions of Spark. And so I played the version roulette for a while and tried to figure out which ones match to what things so I could connect to all my things. And I'm like, man, this is silly. Not just silly, but once I get mine configured, I'm gonna have to walk a junior through doing the exact same thing and configuring the exact same thing. And man, a new release of Spark comes out and we're back in the same boat again. But now, once we have these dev containers configured, we just pass them around. So let's kind of jump into the code a little bit and kind of see what's going on here. So the dev container setup, and this is my repo for my actual base dev container that I pass around. It's called my Golden Python base container. Judge me for the name if you like. I'm okay with it. So dev container JSON is kind of the main crux of this. And I do it a little differently. I also throw a Docker Compose and a Docker file in there, not just my dev container JSON. I'll tell you why I do that. But the setup's pretty straightforward. So I take in this case, I'm using my Docker Compose file, and I should probably start from there, just because that's kind of the base of this, and then we'll work our way back up. So Microsoft has dev container images. I'm using Python 3.11 Bookworm. There's base dev container images that have nothing in them. There's universal dev container images from Microsoft that have everything in them. And when I mean everything, I mean C Sharp, Go, Java, Node, like it's a 3 gig or a 4 gig container and a lot of overhead. But if you're writing all over the place and you just want one thing you can pass around, it's not a horrible thing to have. So my base is 3.11, and then I do little things, right? So I could install this and do anything I want to do to it. So I'm installing DuckDB. I wanted the DuckDB CLI in there, so I grab it, run it, and add it to it. In this one, I also wanted curl and Git, and then poetry because for some of these environment management, I go back and forth between base pip, PyEnv, and poetry and pipx, and go back and forth between UV. I don't know that I've found one that does everything for me. Poetry is kind of my happy middle ground for a lot of things, and I've kind of gotten used to it. But UV is a really strong contender. So if you're looking for a dependency manager for or a package manager for Python, try UV out. It's pretty good. So the normal things in the world of a Docker container thing, right? Like I set the work directory, copy my source code in, Sleep Infinity keeps me running, so it doesn't just kind of spin up and die. If I go to Docker Compose, a couple things I'm doing here that you would want to really dig into. First of all, I map my workspace. The reason I map my workspace is I want to be able to change files that are in my workspace and in my repo from in my container. Now, you can, 100% valid, if you want to not map your workspace and do everything in the container and have a container volume that just contains your work. And then when you go outside of the container, none of those files exist. It's not a complete standard practice, but it's not a horrible idea, right? It's just kind of your choice. And so I always map my workspace just because I like that, bring the files in with me. The next part of this is I like this mapping to the Docker socket outside so that I can run Docker commands in here. Basically, what I do is if I Docker PS or compose up and down, I can add other things to the container and do things. So I always kind of want that Docker socket connected. I'm on my core network. Um, my core network is shared by the core things that I use across tutorials and across different projects I'm working on. So my Postgres is on my core network, and I have one Postgres database on that network in a Docker container, not on my machine isolated, that I have different databases and schemas in for different things. My MinIO, my S3 compatible data lake, right? That's what my MinIO is. And that's on my core network, so I can talk to MinIO directly. I have a bunch of things talking to MinIO, so that's on my core. Those are kind of my two big ones. There's a couple other ancillary things on my core, but those are really my two. Pretty much everything that I'm going to add in and work on is going to hit at least MinIO. And if I'm doing data lake things, my catalogs are going to be in my Postgres. I use Postgres for a lot of my data catalogs if I can help it, just because it's, kind of a good standard workhorse database, good multi-threading. I can connect to a bunch of places. It's well known. It's a good standard of a database. So I put a lot of my catalogs there when I'm playing with things. The other thing that's helpful here is to put your DNS directly. So the dev containers can hit the internet. They just like any other Docker container, you can hit outside things. But when you put yourself on the Docker network, you're at the mercy of the Docker DHCP. So I pick a DNS. Uh, all eights is Google, all ones is Cloudflare. Um, you could do Quad 9, or whatever your favorite DNS is. You could put in here, and this helps you kind of resolve those names outside of the container. So you're not just relying on the baked in kind of Docker network DNS and DHCP and things that are all there. You're doing that at least DNS from the outside, right? Um, Command Sleep Infinity again keeps this thing going. External network is true. For those of you who don't know and haven't messed with Docker Compose too much, the the way the networks work is you have a couple options. You can make this a bridge network and let your compose file manage it, or you can let the network be managed in a different file and make it external and just attach this to it. So when you Docker Compose up, it doesn't try to make that network, it just attaches to it when it exists. And if you Docker Compose down, it also doesn't kill the network. I have a specific network Docker Compose up that has one container with a lot of network tools in it, like dig and curl and just different things you would even use to troubleshoot the network. And I define all of my 6 or 7 different networks there. That way I can control it centrally and I can add things to it. You could technically add multiple networks here. So I could be on core network and I could also be on my open source network, right? Or I could be on another network here. You're not kind of limited to just being on one network. And that's the beauty of it is if you keep these isolated networks on your machine with your Docker containers, and you can just attach to the ones you need or a couple of them if you need those resources. So it's really flexible and kind of in that sense. Um, I'm going to go over here now to the actual container JSON. So a couple things you can do here that I really use a lot. One, you throw your extensions in there. So if there's extensions that you use, your dev container JSON can automatically load those because you're connecting as a dev container with a fresh VS Code. So it's not going to have all of your extensions in there by default, so you can add the ones that you use most often. You see I'm using the Docker one, the Python one, and Rainbow CSV I'm just a fan of. I've liked it forever. There's some other ones that you'll probably like, or there's other ones I'll use depending, but these are kind of my three go-to Python ones. And then features. Features are also really, really helpful because I don't want to always go over here to Docker and manually curl the zip and install it and remove it and do all the things. So Dev Containers has a neat thing baked in, and if I do, I'm already in the Dev Container. You can see it's running. I'm going to pull up either Control Shift P or Command Shift P, depending on if you're on Mac or Windows, and I can configure container features and I can just add things to it. So if I want to go out there and let's say, okay, I need something. What do I need? I need AWS SAM because I'm going to simulate things. I just click the button and rebuild a container. It installs it. If I want ballerina, I got bash command here. I got uh, anything that you can, not anything, but hey, there's DuckDB right there now. So this DuckDB CLI, I could actually remove from my Docker file and put it here as a feature and not have to worry about that install breaking or failing or something being wrong. So that's interesting. I didn't even realize that. So Git's in here. You'll see that that's actually checked. I guess some GitHub things. So you have all these features at your disposal. Mocha, Mongo. You can just click and add, and then they're here, right? Then they are in the container. They are usable by you. You don't have to go fight it. You don't have to fight the installs. As you can see, I can pin a version. I was working with Spark. Spark needs Java 17 for Spark 3.5. So I pinned the version to 17 so I didn't have any version conflicts there. And it just works. Now you may ask, how hard is it to stand these up? How hard is it to do the things? I'm just going to cut mine down. I'm going to put reopen in folder. Basically, these folders, what you need to have is a .dev container folder. Okay, that's the thing. Put your stuff in there. Again, you can get by with just a minimal dev container. Again, I use Docker Compose to connect to networks and then my Docker file because I'm kind of building this and I deployed this. So once you're in here, right, you go down here to your connect and I'm SSH to a server, so kind of ignore that because that wouldn't be there on yours. You would just have the little corner thing. And then if you have the dev containers extension built in, you're going to do the reopen in container. And we're just going to reopen it up. And there it is. So you see how quick that was for me to get back in the container and my environment set up. And I have things here. So let's look at Java version. All right, 17, it's all built in. So we know that everything's installed, everything's here. The first install takes a little longer because you're downloading all the things, but after that, you're up and running in a heartbeat. So the last thing I kind of want to show is how easy it is to kind of roll your own. So this is my own personal one. And instead, now what I do, instead of using this actual file and going to create a new compose, where this says from Microsoft Dev Containers Python, I now do it from my own GitHub IO package center. So let's do this. Let's reopen in folder. And then let's use this one that I'm actually sharing. So let's open folder. You can see I'm in my core infrastructure with all my networks. I'll go back to my source. And in my source, in my source, I have my Andoraya data sets. I'm working on my world engine. As you can see, I have a dev container here. So I'll put the code for my world engine. This is going to be published online anyway. There's no super secrets here, nothing that I care about. So as you can see, all I have in this one is a dev container JSON. right? And I'm just pulling my dev container from my repo that has everything composed in it. I add my customizations, my extensions. I don't really think I even have to here, but this is habit. And then there's some features, some Java features I kind of had to play with because, again, I was dealing with Spark and fighting that good fight. And then, of course, I'm mounting my Docker socket things and binding that. But this is it. This is my 29 lines of code after I've configured my dev container to get up and running. And you'll see this is I'm SSH'd into the local, and then I can just again reopen in container, and I get the full rebuilding container and run. And it's a clean environment, right? Like I can play around with Gradle, Maven, Ant, and Groovy here, and it doesn't affect any of my other containers or my underlining workspace. So that's kind of clean up my desk a little bit. That's kind of the overall of it, right? That's the use of it. And as we're going to kind of go through these demos and go through some of these things, I'm going to try to connect Dev Container to um, the actual repos so that you can have a clean workspace to go through if you're following along and trying to learn the things. Feel free to type that out. I'm not big in, I'm not going to say I'm not big in giving a lot of repos out. I do a lot of open source repos, but I'm against people just clicking and copying, pasting. You don't learn that way. You don't make it sticky. So while you can play with it and while it's fine and while I don't care if you pull my repos down like that, like I have a really good Duck Lake repo, I would encourage you to type it and break it and play with it and add your own spin to it. And when you're doing these videos and when other people do these videos, I would really encourage you not to just click along. Yeah, there's some typing. Yeah, it's a little inconvenient. Yeah, you're going to break things. But that's what you learn. I learned more breaking Spark over the last month than I would have from a tutorial because you get that productive struggle, and then when the answer comes, it's sticky, and you know how to solve that, and you don't forget again later. You've solved that problem, and now you understand how to solve it, and you could help others solve it. So I will have some repos available and of course some dev containers, but they're going to be pretty bare bones. And even if they're not bare bones, if I decide to make full ones, I would encourage you to not just run them, to actually engineer, right? Break things and play with it. In the next videos, we're going to use these setups to explore the 6 modern lakehouse archetypes. If you want to know what that is, I'm kind of putting together what I think are the 6 most widely used kind of architectures for data lakehouses currently. And it's not that others don't exist, and it's not that I'm branding my own flavor of a lake house. It's really what I've noticed in industry and what people are kind of gravitating toward. So if I come up with these 6 and you say, "Oh, I know 3 more," let's talk. Throw it in the comments. Talk those out, right? Let's kind of put a little bit of structure around the wild west that is the lake house right now. Because while I don't want to lock you into things, I think there's really good reproducible patterns here. And I think those patterns are different per team. So we're going to kind of dig into what works for the different teams and why they chose the different architectures. So you've kind of learned why dev containers are helpful. And I say helpful, but for me, they're essential. You kind of see how to build one. More than happy to take comments or emails to walk you through this, help you set one up if you can't, if you like breaking things. Feel free to download this container and play with it. Feel free to look at the repo and make the repo public. So let me know if you're using it, what you're using it for. Comments. As always, like and subscribe, and I'll see you next time.